Alright, hello everyone. So welcome to my integration by parts video series, new video. Okay, so what we are going to do in this video is we are going to solve some very tricky integration by parts problems. Now the thing is that remember, until now we use that LIATE rule to choose U, right? That is a very nice rule. But remember I said you can't use that rule every time for every problem. There are problems that you can't use that LIATE rule, but still you have to use integration by parts somehow. So we're gonna learn how to solve an integral if you can't use LIATE rule. Now here's the thing. Now why can't we use LIATE rule in this problem? Let's try to use it here. Okay, so we have an algebraic function, we have an exponential function here. Okay, so my choice for u is going to be x cubed, right, because a comes before e. dv is going to be e to the x squared dx. Now once you have u and dv, what you need to do is you need to find du and v. Now let's try to find v. So what is v? To find v, we have to integrate e to the x squared. Now can you integrate e to the x squared quick and easy? You can't, right? Because e to the x squared, you can't integrate it using a basic integral. It's not e to the x, okay? And you can't use integration by substitution there either. So it's a little bit tricky. It's a very hard integral to solve, in fact. So we are stuck now. What can we do? Well, you might think, well, our choice for u and choice for dv is wrong. So let's switch them. Let's see what we get if we switch our choices of u and dv, because if LIATE doesn't work, seems to be like that's the only way, right? Okay, let's see. Let's choose u to be e to the x squared and dv to be x cubed dx. Okay, now can we find v? Of course yes. If you integrate x to the 3, it's x to the 4/4. If you differentiate u, you get, well, we have to be careful here. We have to apply chain rule. Now derivative of x squared is 2x times derivative of e to the x is e to the x squared. So I use the chain rule here, okay? All right. Now why did I use chain rule? Well, this is a function inside function e to the x squared. X squared is inside e, okay? So we have to use chain rule when we differentiate. Now du is simply 2x e to the x squared dx. So we have every tool we need to use integration by parts. Okay, so let's go ahead and use the formula. Formula is uv minus v du. Okay, so u is e to the x squared, v is x to the 4/4, minus v is x to the 4/4 times du is 2x e to the x squared dx. Now I want you to focus very carefully here. Look at the second integral while I am rewriting this again. So we can simplify here. So x times x to the 4, it's x to the 5/2 e to the x squared dx. Now do we have a simpler integral here? Can we integrate that real fast? No, right? It's not again a basic integral. So usually integration by parts gives you a very simple integral here. But we saw some cases where we don't get that. We might get repetitive integration by parts, never ending integration by parts. Is that a similar scenario here? I want you to look at this very carefully. Do you think, now it's definitely not something that you can integrate simply. Do you think if I apply integration by parts again, I can get something? Think about this. Think about the change from the original integral here to here. So do you think it became less simplified or less simple? That's the correct way. I'm sorry. Excuse me there. So do you think this is a less simple integral than what we started with? Remember, in the previous problems that we discussed, never-ending integration by parts or repetitive integration by parts, the problem got simpler and simpler when you use integration by parts over and over again. Is that the case here? No. Why is it is not the case here? Because here, look at the power. It's x to the 5. Here, x to the 3. Now the change from this integral to this integral is it increased by x squared, right? But usually in the repetitive integration by parts problems, you might if you can remember, we had x square sine x, then it became x cosine x, then it became just sine x. Remember, it got simpler and simpler, but here it gets complicated and complicated further we move on. So switching u and v didn't work out. So what are we going to do in this problem? So we must have been doing something very wrong. So let me get rid of everything. Now look at the integral again. Now at this point, if you try to do the problem in these two ways, you might be thinking, no, integration by parts is not the way to go about this problem. But trust me, we still have to use integration by parts here. But let's rewind back. Look at this integral now. Okay, so if you look at this integral very carefully, we can see something special there. Now e to the x square, and you have x cube outside it. Now one might think, well, can't we use integration by substitution here? Because it seems to be like I can choose inside function to be x square because it's actually inside exponential function, and then derivative of x square is also outside the integral, right? Derivative of x square is 2x, so you have a x outside the integral. So okay, well, let's try to use integration by substitution. So let me choose my u, or let me use w. Let me choose w. I will tell you why. Okay, it doesn't matter, u, w, it's just an English letter. So w is going to be x squared, that's our substitute. So let's differentiate w with respect to x, so it's 2x. Now that means dx is dw over 2x, right? So we need both of them if we were to do integration by substitution. So let's substitute. We have x cube e to the w. Here dx is dw over 2x. Okay. Now 1x cancel out here definitely, right? So what we get is x square e to the w dw over 2. Okay. Now even though we use integration by substitution, we still have a problem because we didn't cancel out every x term. But x square is actually w, right? If we didn't cancel out every term, we can go back to the substitute. That is something we discuss in the integration by substitution series, okay? We can go back to substitute and see whether we can get any help. Actually, in this case, yes. So this is actually w, right? X square is w. So this is w e w over 2 dw. Okay. So I converted this integral to this integral here. Now the question is, can we integrate this new integral? Well, we can't, right? See, again, it's w times e to the w. It's not a basic integral again. It's a multiplication of two functions, w and dw. How are we going to integrate that? So you might think, well, integration by substitution didn't work. Integration by parts didn't work. Where am I going with this video, right? But I want you to take a big breath and see what can we do here. Look at this carefully. Let's take that half outside. W e w. How can we integrate this? I can use integration by parts here now. Okay, so this is one heck of a problem, right? Because we had to use integration by substitution. Now you get an integral. Now inside that you have to use integration by parts. Yes, you might get these type of problems. The problem is too complicated, so that you have to use a substitution to make the integral less simple, and then you have to integrate that integral by less complicated, right? Yes, I choose the wrong word. So first you have a, let me say that again. First you have a complicated integral, you make it less complicated, and then you use integration by parts. So that's both integration by substitution and parts in the same integral. Wow. So let's use it. Okay. Alright. So here to use integration by parts, now we can use LIATE rule. Okay. We cannot use LIATE rule right away here, but we were able to use it here. Now u is w, dv is ew dw. Now we can integrate v. If you integrate e to the w, you get e to the w. See? It's very easy. If you differentiate dw, you get 1. If you differentiate w, you get 1. So dw is du. Okay, so let's use the formula here. So this is, well, I think I might need to use this. Okay, let's have that half outside. Okay, so that half, so that half times uv minus v du. Remember, we have a half outside the integral. Okay, now half, u is w, v is ew, minus v is ew, du is dw. Now this integral is half w ew. Here if you integrate e to the w, it's e to the w plus c. Okay, so what do we get? So the answer is half. What is w? W is x square. X square e to the x square minus e to the x square plus c. Now this is the solution. We can simplify it furthermore by distributing that half, but let's stop there. Okay, so this is one heck of a problem. We had to use integration by substitution, and then we get a less complicated problem. Then we use integration by parts. So this is a very, very special problem. Okay, all right, try to do this problem again. Try to think about this problem again little more, and try to do it in the wrong way, and try to convince yourself why we cannot use integration by parts right away in the beginning of the problem. Okay, I think this video is a little bit too long, so in next video I'm gonna solve more problems. Okay, so I will see you in the next video. Okay, bye bye.